Welcome to the Lean Manufacturing Workshop. We've created two models that illustrate two different manufacturing philosophies. Push manufacturing, which is a traditional manufacturing processes used in the United States today, and pull manufacturing, which implements many lean techniques. Today we're going to use both models to evaluate which provides the most productive, flexible, and profitable system to manufacture our product. In both models, we're going to build standard and deluxe product as illustrated above. They're going to require the manufacturing, painting, and assembly of bases, shafts, discs, and spools. To get started, let's further define the push and the pull philosophies. Push manufacturing drives production from a forecast. A computerized MRP system, which stands for Materials Requirements Planning, explodes a bill of material against a production forecast and creates individual work orders for each department within the factory. The factory output is then used to fulfill customer orders. If the forecast is a true reflection of the customer demand, then the customer orders will be satisfied without making significant excess inventory. Now let's look at the product that we're building in these models. There are two products, Standard 123s and Deluxe 456s. In this slide you can see the naming convention of the various components. We have small and large shafts, wide and narrow spools, small, medium, and large discs, and bases. Also notice that there's a general sales guidance that we sell twice as many standard models as we do deluxe models. The first model we'll review is the traditional push model. We've already discussed the fact that the MRP is used to drive production in the various departments. Parts are made in the departments and transported to a warehouse where they are sorted and shipped to the next operation. If we look at the product flow in more detail, we see the amount of transportation and warehouse operations. This handling slows down production and does not add value to the product. This is another big difference between the push and pull methodology. The model contains a dashboard which takes inputs from the modeler and instantly shows the impact of those inputs on production and profitability. We'll look at the dashboard in greater detail in the following slides. At a high level, changeable fields are highlighted in orange and they allow the modeler to add resources of people to bottleneck operations or additional inventory to specific areas within the flow. This graphic illustrates the flow of the product through the factory, from the departments through the warehouse to assembly and eventually to shipping. The model allows the user to select various times in the day and get a snapshot of the completed production in all of the departments. This is helpful to determine where bottlenecks are within the operation. The model illustrates the production of a single day. It also shows the percentage of total production within the various departments at that given time and the number of trips between operations. Individual component quantities are displayed for the selected times. This graphic is a subset of the dashboard and it illustrates all of the variables that can be changed to influence a model. Forecast numbers are input here, and these numbers are used by the model's MRP system to create work orders for the various departments. Customer orders can be input into the model in this location. For efficient production, the forecasted quantities and the customer order quantities should be the same. The model also shows the times that the orders were shipped in this column. Factory performance is illustrated here. Note, in this example, the number of forecasts equaled the number that was ordered. All of those were completed and shipped. Nothing was overproduced, and there were no missed sales. In this example, we've increased the forecasts to 18 standards and 9 deluxes, and you can see that at the current staffing and inventory level, we've missed some shipments. So let's use a dashboard to determine where the bottleneck is in our system. The first place we should look is the utilization graphic. You can see that paint has the highest utilization of all the departments. You can also see that only 52% of the parts were produced in the paint department. So it's possible to increase flow by adding a person to the paint department. We can see that by adding a person to the paint department improved the situation, but we still miss some shipments. So all the parts are available in both subassembly and paint, but we're still missing shipments, so the bottleneck is now assembly. So what we need to do now is try to add an additional assembler. By adding the second assembler, we eliminated the bottleneck and all of our product was shipped. This is an example of how increasing customer demand increased the forecast, which required us to make changes to the staffing levels in some of our departments to eliminate bottlenecks and smooth out the product flow. Eventually, adding people will not improve performance because the press becomes the bottleneck. The only way to improve production is to augment inventory with purchased parts. You can add initial inventory to any of the component parts. There are certain parts that become bottlenecks. Adding inventory to these parts will improve production. Adding inventory to the other parts will only increase cost and will not improve production. So it's kind of a hit or miss, trial and error effort. Be aware that when you add purchased inventory, you're paying a premium. Purchased parts are more expensive, and you need to buy a larger quantity to take delivery time into consideration. In this example, your purchased parts price is 4 times more expensive than the price that you can produce them for, and you have to buy 7 days worth of inventory because you only get 1 shipment per week. Adding staff and inventory adversely affects profitability, but missing shipments has a greater negative impact to the bottom line. This is the part of the dashboard that illustrates the financial impact of how the factory is running. By modifying the variables within the model, it's possible to maximize the profit. Another component of the profit equation is the purchase price of the product. This is a changeable variable in the model which has a direct impact on the profitability of the company. The red arrows indicate where you can change the purchase price of the standard and deluxe products. The purchase price of the product doesn't impact production, but it does change the profit picture. It's also possible to view the details for the individual department work orders by clicking on the button View MRP Report. This can be helpful when looking for bottlenecks or other problems. This report is an example of the MRP report and shows the work order details for the press department. Notice it shows the work order number, the item, the quantity, the time it was released and completed, and various costing information. In order to really understand how the model works, you have to work with it yourself. Access the push model and change some variables. Don't be afraid to make changes because you can't break the model. Take the time necessary to understand what is happening in the factory. Assume that you are the plant manager and it's your responsibility to keep both the customers and your shareholders happy.